Thank you all for joining us today. I'm sure most, if not all of you, have heard of Alexa and are familiar with how you can use Alexa to control your smart home. But what you may not know is how you can use Alexa alongside AWS IoT to kickstart the conversion of your devices into smart connected devices. My name is Martin Searle, an IoT consultant with AWS Professional Services. And today, we're not only going to discuss the theoretical, but let a real customer explain how they connected their devices and deployed them into production. But first, it's worth giving a bit of context first. Now, as you're probably all aware, the smart home connected device market has grown substantially in the last few years, especially with the advent of Alexa and Amazon Echo. IDC projects that there might be close to 1 billion devices shipped by 2022. And that is a huge market and a massive opportunity. And so what we're seeing as this growth happens is that our customers are coming to us and saying, we need help with this, right? And they have a number of challenges. So these might be traditional device manufacturers that have unconnected devices. And so they're looking at IoT as a potential way of differentiating themselves. They also note that they have really slow production cycles, go-to-market production cycles. And so one thing that they said was, is there a way that we can make this better? Can we improve our time to market? Can we increase the speed at which we can develop and push data and configuration down to devices? Another thing that we saw consistently is that a lot of organizations have a number of different devices and different platforms, and so they have inconsistent ways of connecting those devices to the cloud. And so they said, well, is there a way that we can more consistently have a more standard protocol to connect all these devices to the cloud and have one central way of managing them? A huge one that we've seen over and over and over again also is that these manufacturers have a lot of hardware expertise and device manufacturing expertise, but zero or very little expertise in building out cloud infrastructure. I mean, traditionally, thinking about someone who maybe builds a light bulb, these people know how to, these customers of ours know how to build light bulbs, but not necessarily know how to build highly scalable, reliable cloud infrastructure. And let's be honest, even for those that do it all the time, that can be a challenge. So that was another thing that we said, well, how can we help them with this? And one thing we'll come back to is edge-based computing, but that's a huge one as well. In the home, edge-based computing is central because we need a way of having these devices interact with each other quickly with low latency and potentially offline. And last, but definitely not least, there needs to be a secure way of having all these devices be able to connect to each other and connect to the cloud. I'm sure I don't have to tell you, you see all the news about all the vulnerabilities and hacks that happen. And so, especially when it comes to maybe manufacturers that have no experience or no prior experience connecting devices to the cloud, we wanted to say, how can we help them make sure that they do something securely so they're not reinventing the wheel when it comes to security, encryption, that sort of thing. So those are some of the challenges they had just thinking about connecting to the cloud. And then on top of that, there was a question of what are some of these trends that they want to get ahead of? So I mentioned, well, they want to be able to move quickly, and they want to be able to leverage all these new connected frameworks, et cetera, to be able to move into the cloud. But what are some of those things? So one, of course, is Alexa, like I mentioned. Customers want to be able to use their voice to control their smart devices. Another is, well, we have all these devices. How can we have them talk to each other? Maybe when I turn the AC down, I also want my blinds to come down to cool down the house. And so there needs to be a standard way of having these devices be able to communicate with each other. Another one is this quick response time. You can't have that change happen, and it take minutes for something like that to propagate. It needs to be quick, and so that really lends itself to making things much easier for the customers. All these different things make it easier for customers to use their devices. They're exciting, and it's a real reason why customers want to go out and buy new products. And there's real practical use cases as well, such as energy management or home security or things like that. Real, practical, not just nice to have, but things that really enhance a customer's, day-to-day life. And so with all of these different things, there was a few core services that we built out in the cloud to help device manufacturers and our customers deal with these problems. So first, I mentioned the reliable and persistent communication. How are we going to have devices be able to have a bidirectional communication to the cloud so that we can not only send data up, but have data be able to come back? It needs to be highly scalable, right? And it needs to be highly reliable. Right? So that was why we built AWS IoT Core. So we have a highly scalable, persistent, and reliable communication to the cloud, something with very low latency. And we did that by leveraging a technology called MQTT. And this is very important. So MQTT is an industry standard. It's now being rolled across the entire industry. And the reason why, it's actually a pretty old standard, the reason why it's now being rolled out is because it actually used to be a satellite communication protocol. So of course you can imagine that a protocol that is used to communicate with satellites is probably a great fit for something with low power or unreliable communication to the cloud, etc. Another problem that we've seen customers have that we wanted to solve was how do we manage these devices, right? So we've enabled them to communicate to the cloud, but what about how do we manage millions of devices and help them create dashboards and push configuration and understand what the state of their devices are? So with that, we launched AWS IoT Device Management. And this is really cool because what AWS IoT Device Management does is allows you to organize your devices into hierarchies with different policies and configuration, and it also gives you the ability to leverage jobs to push updates to devices. It really gives you a lot of great tools to enable your dashboard building to manage your devices. And finally, something we just launched in the last, I think, month or so is AWS IoT Analytics. And this gives you the ability to very easily have a turnkey solution for querying your data, providing machine learning on top of your data and building models. And it takes a number of our backend services and makes them very easy to use and hooks directly into AWS IoT. So with this, you can do things like predictive maintenance and push insights back down your devices to make your customer experience even better. And so these are some of the services that were used by Hunter Douglas. So I'm going to hand it off to them and let Scott talk a bit more about what they did and their history. Scott?
Thanks, Martin. So my name is Scott Stevenson. I'm the Director of Product Management for Hunter Douglas Motorized Shades, and I'm going to spend just a couple quick minutes here with a brief introduction to who Hunter Douglas is and kind of tell you how we fit into the IoT and smart home space, and then I'm going to turn it over to my colleague Lee, who will really talk about how we've been able to use AWS to really improve our product offering. So briefly, who is Hunter Douglas? Hunter Douglas has been around for almost 100 years now. We are definitely the world leader in custom window treatments. When you look across our various brands and across the globe in different markets, on most of those markets we have greater than 50% market share. We're definitely considered a luxury brand. We've been family owned and operated for the entire 90 plus years of our existence. And of that 90 plus years, more than 65 of it has been in the window fashions industry. And again, very innovative as a company in that window fashion space. Pretty much if there is a type of window blind or shade out there that's something other than a roller shade or just a wooden slat type of blind, chances are we invented it. And with that, we have well over 15 years of innovating in motorized shades. In 2015, we launched our PowerView motorized system. If you really think about the evolution of motorized shades and kind of going back to where we started with them, it really just started with a motor in the blind or in the shade and an IR remote that you could point up at that shade and make your thing go up and down. That then evolved into an RF remote, so at least you didn't have to point the remote at the shade. That evolved into having an app, and now within your home, within your local area network, you could control your shades using the app. We then found that our customers really wanted to be able to control their shades remotely and see what was going on with their house when they were outside of their house. So now we needed the app to work remotely. And then that really evolved into full cloud integration and voice control with Amazon Alexa. So really at this point, we're talking about motorized shades that are very smart, very integrated. They're part of the IoT world. They're IoT connected. And with all that, what you really get is something that really enhances the comfort you have in your home, the convenience of being able to hit one button at night or ask Alexa to turn on good evening and have all of your shades go down. And now you feel comfortable in your home. You feel secure in your home. It also can really improve energy savings because you can do things like on a schedule, have the shades on the west side of the house come down and prevent that hot afternoon sun from really warming up the house. So again, we've really been able to use IoT connectivity and everything that, that we can do here to really improve people's lives in their homes. But definitely had some challenges. So with that, I am going to go ahead and turn it over to Lee, and Lee's going to talk about how we've been able to use AWS to really improve what we can do here for our customers. Lee, take it away.
Thanks, Scott. I'm Lee Metcalf, Director of Web Services here at Hunter Douglas. And as Scott mentioned, Hunter Douglas has been selling motorized shades for almost 2 decades. And the evolution of the product brought us to offering our customers an add-on device that we call the Hub. The Hub allowed users to control shades from their smartphones, creating the scenes which are specific shade configurations, and set schedules for them to run. For example, close all my shades at 10 minutes after sunset. One day the customers asked, could we control the shades from outside the home? So we came up with a quick solution. By adding an external server to broker the requests, the Hub will call home every 20 seconds or so looking for actions sent from the authenticated app. A little inefficient, I must admit, with lots of wasted bandwidth. But how many people are really going to want to control their shades from outside their home anyway? Looking back and knowing what we know today, that was a very narrowly focused view. In 2015, Alexa starts picking up steam. The connected home is on the minds of the average consumer. The Internet of Things starts dominating the conversation. Third-party connections are a reality. People start creating IFTT recipes. And what was a blind action outside the home that took 20 to 40 seconds is now an annoyance for users in their home, waiting for an action to happen. Additionally, the rate of adoption of this new offering was growing so rapidly that we were adding servers at a rate of 1 every other week because of the traffic generated from the polling. So how do we solve this? By just dipping our toe in the Amazon IoT services. By using the core IoT service, we managed to establish a persistent connection from the registered hubs, reducing what was a server farm to a single virtual machine instance and reducing our response time to about 2 seconds. But how do we accomplish this, you might ask? We have devices in the wild, and we need to make sure that those get up to speed, get the new code. Thankfully, we had a firmware update process in place previously, and we needed to work on a registration and operation process that used Amazon's core services. So first step was to create an on-demand registration process. Here is or architectural diagram for the on-demand process itself, which seems pretty daunting up front, but really not so bad. How the process work? Well, step 1, the authenticated app in the home sends a message to the hub with a OAuth token. That hub then sends the request to the Remote Connect server. We take that request validate it with the token that we get, and then proceed to broker all the requests over to Amazon. We create the thing, create a certificate, link the certificate, and link the policy. And that package we return directly to the hub. The hub can now directly authenticate to IoT Core. Let's dive into the code and take a look at how that works. First thing we got to do is get an HTTP IoT client. And this object is really the one that does the work at the end of the day. We then use that IoT HTTP client to create the thing in IoT Core. This will give it an ID and an ARN. We take the same IoT client and create a certificate for that thing. Finally, we need to create a policy. But first we have to define what that policy is. So we define this policy, and what this policy allows the thing to do is, in this case, is connect to IoT, subscribe to an action channel specific to itself, and publish to an action status channel specific to it. So the communication is secure and focused. We'll take that policy and attach it to the certificate, then attach the cert to the thing and return it. Following that, we have to take a look at operation, the other side of things. The basic operation is kind of as you might expect. The user outside the home continues sending requests as they did before to the remote server. But now we translate those into a message that we publish to a specific hub action channel. The hub, which is at this point always listening to that topic, takes up the message, signals the shades, and publishes its response to a shade status or a shade status topic. The remote server, which is again subscribed to that action status topic, gets the response and posts a message back to the app. Round trip time about 2 seconds. Again, let's take a look at the source. The hub needs to extend AWS IoT topic to define what should happen when it gets an action. This is really on the hub and or the remote server. We use that defined override when subscribing to our topic with the MQTT client. And finally, to complete the round trip, we have to define our publish method, which uses the MQTT client to publish back onto the topic that we have permissions to. And that's it. That's operation. Expanding this to third parties in the cloud would now be as simple as replacing the phone with a specific third party. So you could imagine IoT thermostats, motion detectors, weather sensors, light sensors, or voice assistants. The design becomes straightforward. Here's our architectural diagram describing our connections to Alexa. Not very complicated at all. The most difficult part is figuring out what your skill will actually do. In our case, our skill actually activates scenes that are predefined. How does this work? The echo in the home with connected skill post-discovery, that's discovered all the scenes that we've pre-created, wakes and processes a voice command. This happens inside the smart home service, which makes calls to our published skill in Lambda. The skill sends a request to the remote server, and the standard operation continues from there through Amazon's IoT and backend to the hub. There are a few other considerations here that we didn't cover in this diagram, but are very important to note. To improve the latency globally, we use GPS information from the hub to find the closest regional POP for IoT services. So hubs in the EU will connect to data centers, maybe in Frankfurt, Asian hubs might connect to a POP in Singapore. And what that does is that helps us reduce the latency in sending messages across the Amazon ecosystem instead of sending them across the internet. So right now we look forward to just more efficiencies as we uncover more and more offerings within the Amazon cloud. But for now, the benefits that we've seen include improved performance, reduced infrastructure costs, lower costs overall, and scalability. Some opportunities that we see looking forward include RTOS at the headrail, green grass on the hub, advanced reporting and kinesis, and the list just continues to grow. I know I'm excited about what's coming next. But I'll leave the description of those up to Martin, and I will hand it back to you, sir.
Thanks, Lee. As Lee mentioned, there's been a number of new services that we've launched just in the last year to really enable customers such as Hunter Douglas to better utilize connectivity in their devices and at the edge. A couple of those that I want to call out are AWS Greengrass and Amazon Free RTOS. So these exist to solve a couple of problems, as you see here on the left. First and foremost, we wanted to find out, is there a way that we can push connectivity even closer to the edge to enable much lower latency for device communication? And so AWS Greengrass provides an MQTT endpoint on the edge that allows both regular AWS IoT devices as well as Amazon Free RTOS enabled devices to connect directly to Greengrass on a hub or gateway at the edge. Now Greengrass has built-in security, the same security that you have with AWS IoT. So you don't have to change how you're communicating with Greengrass or AWS IoT. They work pretty much identically. Greengrass also enables local compute. So in a lot of your devices, you're not going to want to have to run advanced compute or analysis or filtering or things like that on the devices because it might be low power, have batteries, etc. So Greengrass enables you to push Lambda functions, the real live Lambda functions you would have in AWS, down to Greengrass and execute those on top of your MQTT topics. Greengrass also works offline. So for example, you probably want to be able to unlock your front door even when there's no internet connectivity. And so what Greengrass allows is full offline connectivity between your devices. And finally, by leveraging Amazon Free RTOS, with the built-in AWS IoT SDK, we enable you to push updates and control updates from the cloud to Amazon Free RTOS in an easy and secure way. So let's look at how that looks in real life, in a real life smart home environment. So Greengrass, as I mentioned on the bottom right there, would be probably on a home gateway, maybe a Wi-Fi router, etc. And devices such as light bulbs would probably have something like Free RTOS on it. Those could communicate directly with AWS Greengrass. Whereas a device such as a TV, which is much larger, has much more CPU and memory, might not be running Free RTOS, but can still be talking to Greengrass or directly to AWS IoT Core. And with that communication to AWS IoT, we can then enable Alexa. So let's look at what those buckets look like and how that communication flow happens. So you'll see that in the left-hand side there, all the way at the edge, you might have door locks or light bulbs or other appliances. And those can either talk directly to Greengrass in the case of maybe smaller devices, or in the case of larger devices, have them maintain a connection all the way back up to the cloud. If they talk to Greengrass, you'll see that that might be something on your home controller or Wi-Fi router or a hub. Those are going to talk also to Greengrass. So Greengrass will be that conduit back to the cloud. And then from there, you can have the cloud communicate with either your mobile apps, such as Hunter Douglas has, or directly with the Alexa API. And so you can have your Alexa, you can use the Alexa development kit and call Lambda functions directly that communicate with AWS IoT Core. And so with all of these components of the solution, you really have the entire end-to-end piece that you need in order to be able to go all the way from manufacturing the devices all to controlling the devices and configuring them and managing them with AWS IoT device management and IoT analytics. We even just recently announced AWS IoT Device Defender. And what this does is it provides analysis into the communications happening from your device to the cloud, looking for anomalies or devices that might have been hacked. And so to summarize, as you can see, AWS provides the entire end-to-end solution. The deep edge services, including FreeRTOS and Greengrass, all the way into the cloud with device management, analytics, security, anomaly detection. And we do it in a completely managed and highly scalable way for you. So you can have millions upon millions of devices and have no infrastructure to manage. And such as with many of our services, you only pay when you actually utilize your service. So even if you want to have the endpoint set up, you don't pay until you actually send messages to AWS IoT. And most importantly, for those of you especially already using AWS, we have that seamless integration with all of our backend AWS services. So you can use the AWS IoT core and the rules engine if you want to send data to maybe Dynamo or S3 or as was alluded to earlier, Kinesis. It's extremely easy to simply set up a rule to send that directly to those services. And then of course, leveraging the Alexa development kit, be able to send data directly to and from Alexa. Thank you so much for taking the time to participate and watch this webinar. We'd be happy to take any questions you might have.